Section 4.3 has us use factoring to solve for x with a quadratic function. You guys may have touched on factoring in Algebra 1, I'm not sure, but we're definitely going to look at it a lot more. And just so you know, factoring does not go away in math. You have a lot more factoring in other chapters, so you really want to make sure, work really hard right now to get your factoring down so that when you see it again in Chapter 5 and Chapter 8 and whatever other chapters we see it, it won't even be an issue. You'll just be factoring very naturally. So one thing I just want to talk about, your first step of factoring is going to be to factor out a GCF, a greatest common factor. Sometimes if you can factor out your greatest common factor, then the factoring that you have left to do is much, much easier. So a greatest common factor, if we look at just this first example here, first look at the number. Is there a number you can factor out of a 2 and a 6? And so what we're looking for is what's the biggest number that can fit into a 2 and a 6, and that would be a 2 that we can factor out. And then if you have an x to the fourth and an x squared, what can you factor out? What's the most number of x's we can factor out front? And that would be an x squared. So then you have to say, well, what are you left with? If you factored a 2x squared out of this 2x to the fourth, well, the 2's already factored out, so how many x's are you left with? You're just left with x squared. And then plus, if you factor a 2x squared out of 6x squared, so with the numbers, it kind of works like dividing. 6 divided by 2, if you factor a 2 out, you are left with 3. And then that x squared got factored out. So that's all that we have left is 2x squared, x squared plus 3. So here we have what looks like a quadratic function in standard form. And so how we're going to factor this is you look for factors of this last number, 27, that will add up to 12. So we have to think, all right, what multiplies to 27 but will add up to 12? And hopefully we're thinking, oh yeah, it could be a 9 and a 3, because 9 times 3 is 27, 9 plus 3 is 12. And so what we do, if you guys remember factoring where you ended up in parentheses like this, it's going to be x, that 9, because it's positive, will show up as a plus 9, and the 3 is positive, it will show up as a plus 3. So this x squared plus 12x plus 27 factors into this. If we wanted to check to see if we factored it correctly, you can FOIL this back out. If you multiply this through FOILing, you would end up with x squared plus 12x plus 27 if it was factored correctly. We're going to see a lot of different types of factoring. There are some special patterns out there. This one is called a difference of squares. Difference means you are subtracting two terms, and then what are you finding the difference of? Two terms that have been squared. So if we have x squared minus 4, that x is like, or x squared is like an x times an x, so we squared an x. The 4 is like a 2 times a 2, so we must have squared the 2. And then we do see this minus sign is we're finding the difference. So this factoring is quick if we recognize the pattern. Your x's will go here, your 2's will go here, and then we know one sign is a plus, one sign is a minus every single time. And so we could, if we were to multiply this out, we know that we would end up with x squared minus 4. So a couple quick examples again of that factoring a difference of squares. So anytime you have two terms, you want to look to see if it is a difference of squares. So that's an x times an x, that's a 7 times a 7. So we are finding the difference between two things that have been squared. So it'll be x plus 7, x minus 7. Over here we have an x times an x and a 10 times a 10, so x plus 10, x minus 10. So that's what your difference of squares looks like. So why is it that we have to factor? Well, factoring is a great way to actually solve quadratic equations. If you notice, our quadratic equation has two terms with an x. You've got an x squared and an x. These are not like terms, they can't go together. So how do you actually solve for x? And we've got this great thing called the zero product property, that if we can put things in factored form, we'll use the zero product property to solve for x. And I'll show you what that looks like on the next slide. So this first example, if we factor this, start with your last term and say, what are factors of negative 6 that add up to a negative 1? So factors of negative 6 that add up to a negative 1, and we'll say, oh yeah, that's a negative 3 and a 2. So x minus 3, x plus 2 equals 0. So now that it's an equation, we factor it, and the zero product property tells us that if you're multiplying this x minus 3 times this x plus 2, and because we're getting 0 as an answer, that means that either the x minus 3 equals 0 or the x plus 2 equals 0. So we just go ahead and we set them both equal to 0. X minus 3 equals 0, x plus 2 equals 0, and then we just solve them both for x, and we get a 3 and a negative 2. So it'll be very, very common for us to get two answers on these equations. So solve by factoring, that's our method, because if we just have this standard form, x squared minus x minus 6, we cannot solve that for x as it is because we have x's in two terms. So we factor and then set our factors equal to 0 and then just solve those little mini equations.